Okay, 2.7, inverse functions. This is the last of cleaning up chapter 2. What we're going to do in this section is dive deeper into functions. We're going to be looking at two of them at the same time, and we'll see that they're inverses of each other. We're going to look at that mathematically. We're going to look at that graphically. I want to show you what that looks like graphically before we get into it so you can see what we're talking about. We've got this function and this function. The two of them are inverses of each other because they're reflections about the red line. That's y equals x line. You don't need to know that necessarily. But these two guys are inverses of each other, and that's where we're going with this. So let's first look at it a bit mathematically with things that you're already somewhat comfortable with. Let's start with Thomas's worksheet. Number 1 on there. To remind you, you already know this, f of x equals 4x minus 7, g of x equals x plus 7 over 4. This is playing around with composition. This isn't about inverse, but it leads us to it. So let's look at f composed of g. Remember, you're going to start with the g function. The g function is x plus 7 over 4. So we're starting with x plus 7 over 4. We're going to take that and put it into the f function. So I'm taking this piece and I'm going to insert it right in there. So f composed of g is going to look like 4 times x, which is the g function. So x plus 7 over 4, continuing on minus 7. F composed of g, the 4's will cancel. We have x plus 7 minus 7. Those cancel. So we get f composed of g equals x. That's a big deal, that x. Let's hang on to that. Notice that that's an x. Then they ask us to do sort of the flip of that. G composed of f. So that means start with the f function. That's 4x minus 7. And now we want to take it and we want to put it into the g function. Stick it up there. So we will have x, remember x is 4x minus 7 plus 7 over 4. Minus 7 plus 7 cancels. So we've got 4x over 4. So g composed of f is x. Those 4's cancel, and we've got x. That's a big deal right there. That's a big deal that they both end up being x. When they both end up being x, and you can see that in the next line at the middle of the page, two functions, f and g, are inverses if f composed of g of x gives you x, and the flip of that gives you x. The inverse function of f is denoted by f to the negative 1. So we could say that f of x equals 4x minus 7, and f of negative 1 of x, the inverse of that, is this guy, x plus 7 over 4. Because whether we're fogging or golfing, either one, we get x as a result. Remember, we're just starting this, so if it doesn't make a whole lot of sense to you, no big deal. That's just a reminder there of how to do f composed of g and g composed of f. Okay, let's look at number 1 beneath the first line there. Let's see how I'm doing on you being able to see this mess. Okay, good. Good place to scoot it in. Which reminds me, just pull it all the way down here. Yeah, that's good. Which reminds me that if you see something on these videos that you think I could do a better job of, please let me know. I know I need to write large, probably need to write larger. I also learned that putting this graph over here doesn't create a white blob, but this does, a shiny blob. So I learned from that, but if you find something else as we go, please let me know. Okay, number 1 says determine whether the two functions are inverses. So we've got f of x equals 3x minus 5 and g of x equals x plus 3 over 5. There are some funky things going on here. Do you see where we're multiplying times 3 here, but dividing by 5 here? That's not an inverse. Inverse operations, if I'm multiplying here, I need to be dividing by 3 here. I'm subtracting 5 on f of x. I'm adding 3. I need to be doing the inverse operation. Remember back above on the one that we did that we found were inverses of each other. Let me take us back up there. You can see that we're multiplying times 4 here and we're dividing by 4. We're subtracting 7 and we're adding 7. So this is the inverse operation happening on x and the inverse operation happening to the tail, to the constant. So that's a pretty decent indicator that we're looking at inverses there. Number 1, I can promise you we're not looking at inverses, but you have to be able to prove it. So remember, what we want to do is make sure that f composed of g is an x and g composed of f gives you an x. Let's see if that happens. F composed of g of x. We're going to start with g, that's the fraction-y one, and we're going to plug it in here. We're going to take this guy and we're going to x plus 3 over 5 and plug it in right there. So the setup is 3 times x plus 3 over 5 minus 5. So we're going to get, you could multiply the numerators. Minus 5. That's never going to clean up. This is 5 does not go into 3, does not go into 9. That's not going to give us x. We can mess with this a little bit, but we're still going to end up with 3x over 5 plus 9 over 5 minus 5. You could combine those two like terms if you cared to, but remember the point is the thing asks you to determine if they are inverses. We can already tell we didn't get x out of this, and we need to be able to get x out of this. Just to, show it both ways, g composed of f, start with the f function, that's 3x minus 5, plug that into that x, into g. So that will give us, instead of x, we're going to put 3x minus 5 plus 3 over 5. We're getting numerator simplify, and we're getting a mess. We're getting 3/5 x minus 2/5. That's not x. This is not x. So no, these are not inverses. It's a simple enough yes-no answer on that. Let's look at number 2. They're telling you these are inverses. The following functions are inverses. H of x equals 4x minus 7, and h inverse of h of x equals x plus 7 over 4. These are the two we looked at the top of the page where we were being reminded how to do composition, function composition. So we've got multiplied times 4 divided by 4, subtracted 7, added 7, and we already proved up above that they are inverses of each other, because both of them gave you x. When you did f composed of g, you got an x. When you did g composed of f, you got an x as the answer. So we know these are inverses. They're asking you to find the inverse of h composed of h of 8. So they want us to plug 8 into the h function, into this one, and then take that answer and plug that answer into this function. So let's see what happens. When we do h of 8, we're going to grab the h function and plug in an 8. So we get 4 times 8 minus 7, 32 minus 7. We're getting a 25. So hold on to that 25, and we'll go further with that 25. H of 8 gave us 25. So when x is 8, we get a 25. Now we're going to take this 25. Remember it said first do h of 8. We did that. Now let's take that 25 with us and go to the inverse function. So h inverse of 25 equals 25 plus 7 over 4. The inverse function, 25 plus 7 is 32, and 32 over 4 is 8. So when we stick it in the inverse function, we get an 8. That means the x was a 25, the yield, what we got out of that, was an 8. See how these are opposite? That's always going to happen, that the x becomes the y and the y becomes the x on inverse functions. They invert each other. They swap places with each other. It's just sort of excuse me, moving across, that kind of thing. Always that will happen. We're going to use that a lot for the rest of 2.7. A lot. That's the basic idea, that x becomes y, y becomes x in inverse functions. They're just sort of playing opposites with each other. And in fact, we're using it right now. Let's see. Here we go. Okay. Let's look at number 3. Number 3 says, for the following function g, find the inverse of g for -4. So they're telling you the set of g is composed of -7, -4, that point, -4, 7, that point, 3, -7, that's a mess there, but we're not going to use it anyway, so it's okay, and 9, 3. So they are asking you what the inverse function for -4 is. So what that means is that if this is g and this is the inverse of g, that means that this is the secondary number. This is the y right here. This is like the 25. So in this, with inverse functions, the inverse will give you the y. They're asking you to find the x. So we know that somewhere in this set of points, we've got a point that has -4 as its y, and we're looking for its x. And that's pretty easy. I mean, here it is. -4 is the y. So -7 is the answer there. The inverse function of g for -4, whenever you see the inverse, they're going to give you the y for this function. These two functions are playing opposites. So instead of that being an x, it's a y. So we find it and locate it right there. So -7 is the answer. It's an opposite day thing. That's an opposite number. You know, you got that. They're giving you the y, you give them back the x. That's the bottom of page 1. Let's see what we're going to do following this up. 4, 5, 6, and 7 all ask you to find the inverse. It's a step-by-step process. You can see those 4 steps. That may look daunting. You're going to have it memorized by number 6 and certainly by number 7. This is an easy thing to do. So let's look at number 4. It's over there on the right-hand side. Find the inverse of f of x equals 3x minus 5. So it's multiplying 3 and subtracting 5. We want to do the opposites of that kind of thing. The first thing you do is take away this function notation and make it a y. Just replace it with a y. Then remember up here, y's are x's and x's are y's when you're moving from the regular function to the inverse. So let's swap out these two letters. X equals 3y minus 5. Okay. Now we're going to solve for y. So we want to get the 3 and the 5 over on the left-hand side. Well, if you're solving for y, what's the first thing you're going to do? You're going to move this minus 5 by adding 5 to both sides. So we have x plus 5 equals 3y. Still trying to solve for y. So we'll divide by 3. So we get y equals x plus 5 over 3. What I want to do with that is I want to flip it around. And now that we've got it solved for y, let's remember that this is the inverse. So we're going to say f of negative 1 of x equals x plus 5 over 3. And there's the answer. Notice that from the function to the inverse, this is multiplied times 3, this one's divided by 3. This one's minus 5, this one's plus 5. That's what's going to happen each time. Let's do number 5. Number 5 starts out, f of x equals 2x plus 8. If you're feeling comfortable here, put me on pause and see what you can do with that. See if you can rearrange it following these steps if you want to, wherever you are in this process. If you're not ready for that, don't do it. Just hang on. We'll have 2 more chances after this. And that's really the beauty of you learning through YouTube, because you can stop it. You can stop me and do your own thing for a little while. Okay, the first step we want to do is get rid of the function notation and put in a y. Second thing we want to do is just swap out the y and the x. That's exactly what's happening with inverse functions. The x gets up and moves over to the y, and the y gets up and moves over to in place of the x. So we get x equals 2y plus 8. And now you're going to spend some time getting y by himself. Isolate the y. So you're going to move the 8 over first. X minus 8. Still trying to solve for y. So we're going to divide both sides by 2. So y equals x minus 8 over 2. I'm going to have to do a little bit of repair here, but I can't just cancel these without canceling a 2 off the x, and I can't, so I'm going to have to separate. X over 2 minus 8 over 2, and of course 8 over 2 is just 4. Now let's swap these out where y comes first. And then in place of y, let's put in function notation again. There's the answer. And notice that, where do we start? 2 times, we're dividing. Instead of multiplication, the inverse is to divide. Instead of adding, we're subtracting. And we have divided by the 2. I know that doesn't look like the same number, but that's okay. That's good. That's a good answer. Okay, let's look at number 6. Number 6 asks you to find the inverse. G of x equals 4x cubed minus 1. And so let's go through the steps. Cancel this out, put a y. Then what we want to do is we want to swap these 2 out, because that's what inverses is all about. Put the x there, the y there. And now we're going to spend a goodly portion of this problem isolating the y. And you know the first thing you need to do is get rid of the things that are further away. So I'm going to plus 1 and plus 1. I'm still trying to get as close as I can to y. So the next thing I'm going to do is divide by 4. And then in order to isolate y, this is y to the 3rd power. What I'm going to need to do is take the 3rd root of it. That's the opposite, and that will isolate y. Cubing something and uncubing something cancel each other out. So raising it to the 3rd power, like let's take 2. 2 times 2 times 2 is 8. And taking the cube root of 2 times 2 times 2 gets you back to just the number itself. So cubing and uncubing cancel each other out. Whatever you've done to one side, you're going to need to do to both sides. So we're going to get the cube root of x plus 1 over 4. Okay, let's look at number 7. Give me a minute. I got to swap this out. Got a little messy there. Okay, let's send the table back to the other end. I tell you, I'm just about ready for Hollywood. Be a cinematographer or whatnot. Where's the end? Shoot, I can't see it. There we go. Okay. So we are looking at number 7 right now. Still finding the inverse. So we've got, hey, you know what, on that previous one? I didn't finish it. Let's see, right here. Get it up here a little bit. Right here, not finished. I just bailed on it. So let's reverse the two sides, and then let's change this out. This was g of x, so this will be g of -1 of x equals the cube root of x plus 1 over 4. So I just didn't finish it up. Okay. Now number 7. We have h of x equals the square root of x minus 5 plus 4. And I think, no, we're good. Okay. So we're doing the same thing. Get rid of this guy, put a y. Then we want to swap out the x with the y. And then we want to solve for y. That's our job for the next few steps, to isolate y. So move the 4 over, minus 4 on both sides. And then this is the square root. We're going to have to square both sides. So we want to take this and square it. Unsquaring and squaring are opposite things. They're just opposites, so they cancel each other out, so we get y minus 5 for that. If you square one side, you have to square both sides, and I'm hoping that you remember that that means x minus 4 times x minus 4, FOILed out. So first gives us x squared, outside gives us -4x, inside's another -4x, and last is plus 16, so that's x squared minus 8x plus 16 when you FOIL it out. Still trying to get y by itself, so add 5. So we're getting x squared minus 8x plus 21 is y. Flip them around. And then in place of y equals, you want to write in place of y equals, what do we have? We had an h up there. So h of -1 of x equals x squared minus 8x plus 21. So those are inverses of each other. What we started with, what we ended up with. We just literally swapped out the x and the y, and that will give us inverses once we solve for the other variable. Okay, where are we going next? Let's go to the next page. Okay, at the top of this page it says, do all functions have inverses? Consider f of x equals x squared and attempt to find the inverse function. I mean, you can tell by the wording that this is not going to work, but let's find out why it won't work. So make that a y. And then we're trying to swap them out. So x equals y squared. And now if you've got y squared there, you need to take, sorry about that. Let's start over. This will not be perfect, and sometimes it won't even be pretty. Okay, that's high enough, I think. So we started with f of x equals x squared. Change out the f of x for a y, and now swap them out. Literally put them in each other's places. And you want to solve for y. So this is squared. You want to do the opposite of that. the inverse operation of that. Instead of squaring, you're unsquaring. If you do it to one side, you've got to do it to both sides. And so what we've created here is y equals, you put the radical on, so you have to consider both a positive and a negative x. And here's the problem with that. Up here, it wasn't a problem because we can put in 3, and if we square it, we get a 9. We can put in a negative 3 for x, and if we square it, we get a 9. That doesn't violate the function rule, the skank rule, where you can't have x dating the same guy. The same guy can date any number of people he wants to. But when we reverse this, this is a problem, because what this says is that if, I'm missing something here. No, I'm good. Oh, I lost my radical x. There we go. Okay, now we're good. I just left it off. What this is saying now is that let's say that x is a 9. Then the square root of 9, put the 9 in there, the square root of 9 comes flying out as a positive 3. Well, that's not a problem so much, so y is a 3. But it can also come flying out as a negative 3. So if we had a 9 there, the square root of 9 is a 3 with a negative on it. And this is a problem. That's not a function. So when the inverse creates this problem, we're stuck. We're not going to be able to do this. So this will not work. You won't be presented with ones like that. But the reason it won't work is because the x is paired with 2 different y's. I'll show you some results of that every once in a while, and you can see how that works. But for right now, we're going to look at how you can tell that you can't do this. So in the next paragraph, it says identify one-to-one functions. If a function is one-to-one, then it has an inverse function. It'll be legal to do this. And in between those 2 lines, a function, y equals f of x, is a one-to-one if no horizontal line intersects the graph in more than one place. Okay, let's talk about that. Let's look at number 8. It's asking you to state whether it is one-to-one or not. And I'm just going to grab a couple of the idea of the points and get the spirit of this problem. Won't get these points exactly, but the spirit of this problem is here. What we are learning here, first off, is it a function? A function means, and you know this, a function is if you drop any vertical line down, it will not hit any one of these points more than once. So it passes the vertical line test. We already knew that because the problem says state whether each function. So it passes the vertical line test. This is guaranteed to be a function. Now they're asking us, is it one-to-one? That's the flip side. That's the inverse of this. So this creates, if you're asked to find is it a one-to-one, that means it has to pass the horizontal test, horizontal line test. So can you run any horizontal line through here? If you hit one of our points, you're good. If you hit 2, it flunks the horizontal line test, and it's not a one-to-one, and so we cannot create an inverse for it. So it's got to be able to play both ways. This one does. Any horizontal line I draw is only going to hit each one of our points, just one of our points at a time. It never doubles up on the points. So number 8 is good. Number 8 is a one-to-one. The question asks you state whether each function graph below is one-to-one. So number 8 is one-to-one. Let's look again at number 9, or let's look now at number 9. You know what I did? I did it. I used Sharpie on this. I didn't grab my other ones. Well, that's going to make life difficult from now on, isn't it? I'm going to have to, I don't know what I'm going to do. I'll play around with something to, okay, so, crap. Let's look at number 9. I'm drawing this in red. This is my function. We know it's a function because they told us it was a function. The instructions tell you it's a function. It asks here to state whether it is one-to-one. Does it pass the horizontal line test? No. If I were to bring through a horizontal line, it would hit there and there and there and there and there over and over and over. That flunks the horizontal line test. So number 9 is not a one-to-one function. Let's look at number 10. Number 10, looking at the red here. Number 10 looks somewhat like that. Does it pass the horizontal line test? Yes, it does. Any horizontal line I draw will hit the red only one time. So it's good. So number 10 is one-to-one. It's a one-to-one correspondence. It is, we can play inverses with it. Okay, the fun starts on number 11. Number 11 is asking you to draw that onto a graph. I'm not happy about this. Let me use red. So let's see what these points are. Let's start there. Let's look at number 11 and see what the points are. So the first point I see on number 11, I'm going to grab this one down here, and this one is -4, -2, -4, -2. Then this point is -3, +1. Then the next point over is -1, +2. And the last point on this graph is 1, 4. So we've got those 4 points, and this is on f of x. That's on the regular graph that they've given us on this problem. They're asking you to graph the inverse function. The inverse function is going to be these dots, this segment, transferred across this reflective line over here. It's very, very simple to do. Are you even looking at that? Do I have that in your scope here? Yeah, good. So what we're going to do, super simple, it says if AB is on the graph of a function, these are A's and B's, then BA is on the graph of the function that's the inverse. So if we want the inverse, this will be f of -1 of x, the inverse. All we're going to do is swap out these two numbers. So instead of -4, -2 being our point, -2, -4 will be our point. 1, -3, swap them out. 2, -1, swap them out. 4, 1. So that's what we want to graph now on the graph board. You're just going to have to put up with all this mess that I've done. I'll see what I can do about cleaning up. I'll Google that. So let's see what we want to do. Let me bring this down. I'm hoping you have the points there. Yeah, you can still see them. We want to graph 2, -4. Let's see, let's put the original ones on there. -1, 2, 3, 4, -2, -3, 1, -1, 2, and 1, 4. Okay, so this in red is our little graph that Thomas gave us. We want to project that across y = x line, like this is a mirror over to this part. Let me grab a different color. Let's use blue here. So blue will be the inverse color. So if your brain can do it, you can just pop them here and here and here. I'm not so good at that, so I'm just going to use my chart. -2, -4. That's the reflection of this guy. 1, -3. 1, -3. That's the reflection of this one. See, it's a good distance away. It's a good distance away. Next, 2, -1, is right here. That point corresponds with this guy. And finally, 4, 1. This guy corresponds with that one. So let's connect the dots here. And there we have the reflection, we have the inverse. So let's see, this guy is the function itself. This guy is the inverse, f of negative 1 of x, the inverse of that f function. So that's all they're asking you to do on 11. Write a chart, take the points that you're given, flop them out, just swap out, invert the two columns, and you've got the new set of points that goes there. There's an important thing going on the bottom of that page. It says the domain of f equals the range of the other guy. The range of f equals the domain of the other guy. So in the same way that the points swap each other out, the domain and range swap each other out. So if I'm the domain of the function, I'll be the range of the inverse. If you're the range of the function, swap it out. You'll be the domain of the inverse. And we'll look at that a little bit. I don't think we need to look at it here. We've got enough practice going on later that we can look at it. If you want to look at it in class, that'd be fine. Just ask and I'll draw some pictures on this mess I'm making here on this thing. Okay, so let me get rid of the points I can. Let's look at number 12. Is that where we are? Yeah, we are. Number 12. Okay. 12 says consider the function f of x equals x plus 7 squared for the domain, and this is such an important piece of what we're going to be looking at, and I'll show you what it means to us, for the domain of negative 7 to positive infinity. We need to find the inverse, find f of negative 1 of x, and we need to state the domain of f of negative 1 of x. So we need the domain. Okay, let's go to the graph for that. Let's first draw this function on the graph. What we know is that this is a parabola, x squared. It's a parabola. You know that. And you also know that this is a liar, so it's going to scoot over on the x-axis a minus 7. So let's see where we're going. 1, 2, 3, 4, 5, 6, 7. Right here is its vertex point. Remember, it's negative 7, 0. What this graph looks like, it goes over 1, up 1, over 2, up 4. So heading up there. It looks something like this. Something like that in the red. It says for the domain negative 7 to infinity. So they only want us to consider on the x-axis what starts at negative 7 and goes on to infinity. So they want us to only consider right here and to the right, not this piece. So they're asking us to take that piece out, just take it completely out, and we'll start our little guy right here at negative 7. So that's the only piece we want to look at. They're asking us to find the inverse of that, and we could certainly do the whole thing where we write y equals x plus 7 squared, and we could swap them out, and I will do that in a minute. But I want to show you that probably for some of you it's just easier to do an inverse kind of thing. So with points, considering points, f of x, let's see, this is negative 7, 0. This point, it goes through negative 6, 1, and then it goes through negative 5, 4. I happen to know that. We didn't talk too much about that. I told you to sloppy graph it. But what they do, what parabolas do, is they scoot over 1 and up 1. We did a little bit of that. And then over 2 and up 4. Talking about his little beady eyes and his ears. We did some of that. So if we want to go and look at the inverse, f of negative 1 of x, swap them out. 0, negative 7, 1, negative 6, and 4, negative 5. Let's go see what that looks like here. Let me use blue for that. 0, negative 7, 1, 2, 3, 4, 5, 6, 7, down here. 1, negative 6, and 4, 1, 2, 3, 4, negative 5. 1, 2, 3, 4, 1, 2, 3, 4, 5. Yeah, okay. So this thing is going to look like that. And that is the inverse of, these two guys are inverses. This is f of x, this is f of negative 1 of x. They are reflections across that mirror, the y equals x line. Now, if you wanted to prove this, or if you wanted to find f of negative 1 of x, you'd go through the routine. Take this equation, make that a y, swap them out. You need to take the square root there of, we need to get rid of this square root, the square, so take the square root of it. Then we have got y plus 7 equals the square root of x. I'm going to subtract 7 from both sides. So we get y equals the square root of x minus 7. And here's the important part. Whatever we're putting in here for x, they limited us to just using negative 7 to infinity for the range. And so we're not going to be able, remember this domain, the domain for f of x will be the range for our new guy, for our blue guy. So if the range is limited to negative 7 to infinity, the range cannot go down here. That's why we don't have to put a plus or minus here. You don't have to worry too much about that at all. Remember, this is number 12, and you don't even have one like this on your MyMathLab. This is just learning, so just enjoy it. So what we've got here then is, then let's swap them out, and then take that away and put f of negative 1 of x equals the square root of x. Let me do that again. This is not right either. So this will be y equals the square root of x minus 7, and then f of negative 1 of x equals the square root of x minus 7. That's the inverse function. That's what graphs this, square root of x minus 7. So move down here. It's the inverse of this one. Let's see, they're asking us for the domain of this guy. So let's look at the domain. Remember, the domain is what is happening on the x-axis. So the x-axis, just looking at the blue, the domain, nope, it's not using it, doesn't use it till right here, 0 to infinity. So the domain for this guy is 0 to infinity. Are you getting that? I hope so. If not, I apologize. I think it was good. So the domain here is 0 to infinity. That means, remember, that this guy's domain, this is the inverse, is the other one's range. And sure enough, if you will look at our graph, the range, what did we use up on the y-axis? Here's the y-axis. Slide this guy over to see what he uses up of the thermometer. He uses up 0 onto infinity. So the domain of this guy is the range of this guy. The range of this guy is the domain. They're opposites, just like the a's and the x's and y's swap out places also. Okay, I think we're done with that one. You will not have to worry about one like number 12 on your homework, or of course then for your test. We'll look at my worksheet next, and you'll see that the work is quite similar. A little bit more graphing, but we'll get there.